Hello friends, welcome to the Engineering Projects YouTube channel. I am Mariam. We have started the series of electronic devices and circuit theory by Robert L. Willisted. This is our chapter number 1 and its name is semiconductor diodes. This is the last topic of our chapter and its name is filters. Today in our lecture we will discuss about filters. In our previous lectures, we have discussed about semiconductor, diodes, light emitting diodes, photodiodes, Zener diode, ideal and practical diode, rectifiers, full wave rectifier, bridge rectifier, center tap rectifier. And in our last lecture, we will discuss about filters. What are filters? The devices used to remove the AC component of the rectified output but allows the DC component to reach the load is called the filter circuit. So basically we have to know about the terms AC component, rectified output and the DC component. So all of the components which are in the form of like this or this, it is in the form of AC components. So half cycles are the AC components of the rectified output. What is rectified output? We have made the series on rectifiers. If you have not watched our lectures on rectifiers, then I have provided the link in the description. Kindly watch our lectures. It is important to watch these lectures because filters are based on rectifiers. So rectified output is basically the function of rectifier is to provide us the DC output. The function of rectifier is basically to provide us the DC output. But this DC output contain the AC components, like we will have the rectified output in this form. But this DC output contain the AC components. We want to remove these AC components by the filters. So remove the AC component of the rectified output but allows the DC component to reach the load resistance is called the filter circuit. We have the 4 types of filter circuit. These are the inductors filter, capacitor filter, LC filter, inductor capacitor filter and the pi filter. And the pi filter will be in the form of CLC. It is the capacitor inductor capacitor filter. Now we will discuss about these filters one by one. First one filter is inductor filter and it is applied, it is inserted between the rectifier and the load resistance. This is our transformer, this is our rectifier and this is our load resistance, and between the rectifier and the load resistance we inserted our filter which is the inductor, and it is inserted between the resistance and rectifier and it is in the form of series, not it is connected parallel, it is connected in series. AC will be blocked and DC will be obtained. At the final output, AC will be blocked but DC will be obtained. What is the function of filter? What is the function of this inductor? Inductor function. So the function of inductor is to DC to pass and block AC component. So basically this filter, this inductor filter will allow the DC to pass and will block all AC components. Not all, sorry. All AC components will not be blocked. Some AC component will pass through the circuit. So this will be the final output. This blue line indicate the rectifier output. This blue line, dotted blue line indicate the rectifier output and the red line indicate the filter output. And after filter output we will get the DC component, and this DC component will also contain some ripples, will also contain some very small amount of AC components. Now we will discuss about our second filter which is the capacitor filter. So capacitor filters, what are capacitor filters? The function of inductor is to pass DC, but the function of capacitor is opposite to inductor. It will pass AC and block DC. It will pass AC and block DC. It is connected in parallel to the load resistance. So you can see here it is connected in parallel to the load resistance, but this filter is connected in series with the load resistance. Capacitor get charged for rise of voltage and get discharged for fall in voltage. So here is the rise of voltage from this to this. At the center, here is the rise in voltage and here is the fall in voltage. For rise in voltage, our capacitor will be get charged, and for fall in voltage, it will be get discharged and provide all of its output to the load resistance R. So here again is the transformer. This is our rectifier. This is our filter F, and this is our load resistance R. And this is the circuit for center tap transformer. If you have not watched the lecture on center tap transformer, then the link is provided in the description. Kindly watch the center tap transformer. We have positive here. Let us say we have positive here and negative here. The function of transformer is to provide the AC supply. When positive here and negative here, our diode D1 will be charged. Our diode D1 will be forward biased and it will act as the closed circuit. Our diode D2 will be reverse biased and it will act as open circuit, because our P is connected to positive and here P is connected to negative. So we will get our rectified output here, and our rectified output will be in the form like this, and this rectified output will pass to the capacitor. We will get our output here. Now at this point, the capacitor allow to pass AC and it does not allow to pass DC. So AC components will be passed here and DC component will allow to move in front. So we will get our DC output at along the load resistance R. So here we will get DC component, and this is the form of DC component, and similar will be here. Similar, it will get closed circuit and it will be act as open circuit when here is positive, when here is negative, and all of the DC will allow to pass from this filter, and we will get output in the form of DC, and AC will be blocked here. So it is the charging and discharging process of our capacitor filter. It get charged from here to here and it get discharged from here to here. So now we will discuss about LC circuit. Now we will discuss about LC filters. Now LC filter contain the inductor plus capacitor filter. So it is the combination of inductor and capacitor filter. So for the inductor filter, our ripple factor is directly proportional to the resistance. But for the capacitor filter, our ripple factor is inversely proportional to the resistance. Ripple factor is basically the amount of ripple. So our ripple is directly proportional to resistance, and in this case our ripple is inversely proportional to resistance. So our ripple factor in LC filter will becomes independent of resistance. Ripple factor will become independent for LC filter. It will become independent of resistance. For LC filter, we have the ripple factor like, for LC filter, we have the ripple factor like this, and it will get independent for LC filter. This is the circuit diagram for LC filter. We have not shown here the rectified circuit. When we show the rectifier circuit with the LC filter, it will be get too much complicated. So that's why here we have connected the rectifier. I will simply use the term rectifier. I have not drawn here the circuit for rectifier. We will have the rectifier output here, and this output will pass through the inductor, and this inductor will allow the DC component. This rectifier will have the output like this. This output contain the AC and DC components. So this output will pass through this inductor, and this inductor will allow the AC to pass, and it will block the DC. This inductor will allow the DC to pass and block the AC components. So DC components like this will be passed from here, and AC components will be blocked here. These AC components will be blocked here, and DC component will pass through the inductor. But this DC will contain small amount of AC components. Now the function of capacitor is to pass the AC component and block the DC components, and it is connected in parallel to the load resistance. So here we will have the DC component and very small amount of AC component. These AC component will pass through this capacitor and will be ground here. These DC filter, these components will be ground here. Now these AC components will be ground here, and the DC component will pass here and approaches the load resistance, and we will get the final output in the form of like this DC. It will contain very small amount of AC. Now L allow to pass the DC, blocks AC. C allow to pass AC but blocks DC. Now we will discuss about pi filters. C, capacitor, inductor, capacitor arranged in the form of pi. It is mentioned here, capacitor, inductor and capacitor are arranged in the form of pi. C1 blocks the DC. This C1 will block the DC component. This is our rectifier output, and our rectifier output will be in this form. This rectifier output, at this point our DC will pass and AC, our DC will block and AC will pass here. So at the final, at this point we will have such kind of ripples. Now this DC will pass through this inductor. This DC contains small amount of AC component allow to pass from inductor. This DC will allow to pass from inductor, and the function of inductor is to allow to pass DC and block AC component. So the AC component contained in this output will be blocked by this inductor filter, and we will get at this point the output like this. Now our ripple factor will be low for this at this point. Our ripple factor will be very low. Now to pass through inductor, it will contain very small amount of AC component. Here you can see here it contains very small amount of AC component. Now this DC blocked by C2. Now here this DC is blocked by C2. This C2 will allow to pass the AC component and block the DC component. AC component will pass here, and our final pure DC will be obtained at load resistance R. DC blocked by C2, but very small amount of AC will pass through C2 and we will get pure DC at final output. So we will get the final output like this. So our DC will be in the form of pure output. Our output will be in the form of pure DC. So this is all of our lecture. In our book we have seen the term reactance. REACTNC. So reactance is basically the internal resistance of capacitors and inductors. For capacitor, the reactance for AC is very low. The resistance for AC is very low, but the reactance for the DC is very high. But for the inductor, the reactance for the DC is very low and reactance for AC is very high. We have to note this term because it is mentioned in our book, so that's why we have discussed about this term. This is all of our lecture, and in this lecture we have discussed about 4 filter types. I hope you will like our lecture. If you like, then kindly subscribe our channel. Thank you.